The ocean floor is not just silent. It remembers. Nearly 4 kilometers beneath the surface of the North Atlantic, in complete darkness and crushing pressure, the seabed surrounding the Titanic has become something else entirely, a crime scene frozen in time. When remotely operated vehicles descended to search for the Titan submersible, they weren't looking for answers at first. They were looking for signs. And what they found scattered across the ocean floor would later raise disturbing questions. Instead of a single wreck, the cameras revealed a debris field. Fragments of carbon fiber, twisted metal components, and structural elements lay spread across a wide area. Not burned. Not crushed against the Titanic, but dispersed, violently, as if the vehicle had ceased to exist in a fraction of a second. Experts immediately focused on the pattern. On the ocean floor, debris tells a story. If a submersible fails slowly, parts collapse inward and remain close together. But here, the spacing of the fragments suggested something far more sudden. An implosion. The pressure at that depth is over 6,000 pounds per square inch, enough to crush steel like paper. The Titan's hull, made from experimental carbon fiber layered with titanium, was designed to resist that force. But the seabed evidence hinted that resistance may have failed instantly. One of the most haunting discoveries was the absence of large intact sections of the pressure hull. Instead, what remained were shattered components, reduced to fragments, a sign that the structure did not deform, it collapsed catastrophically. Nearby, the Titanic itself stood unchanged, as it has for decades, a massive steel monument to a different era of engineering. The contrast was chilling. 2 vessels. 2 eras. 2 very different endings. As investigators continued to map the debris field, another unsettling detail emerged: personal items. Small objects, believed to belong to the passengers, were found among the wreckage. Items that had no structural function. Items that had been inside the submersible just moments before it vanished from radar. The ocean floor had preserved their final position. And with every new scan, one question grew louder. If the seabed can reveal how the Titan failed, what else might it be hiding about why? As investigators analyzed the debris field in greater detail, attention shifted from what broke to a far more uncomfortable question. What failed first? The Titan was unlike any other deep-sea submersible ever used for missions at Titanic depth. While traditional submersibles rely on solid titanium or steel pressure hulls, Titan's core structure was built from carbon fiber composite, a material strong, lightweight, and widely used in aerospace, but rarely trusted at extreme ocean depths. On the ocean floor, fragments of this carbon fiber hull told a troubling story. Unlike metal, which bends and deforms before collapsing, carbon fiber fails silently. It does not creak. It does not warp. It fractures suddenly, and when it does, there is no warning. Recovered debris showed layer separation, a phenomenon known as delamination. This occurs when repeated pressure cycles weaken the internal bonds of composite materials. Each dive to extreme depth becomes a stress test. Over time, microscopic damage accumulates. The ocean floor suggested that this damage had reached a breaking point. Data logs from previous missions revealed that Titan had completed multiple dives to similar depths. Some experts had raised concerns years earlier, warning that carbon fiber might degrade unpredictably under repeated compression. Those warnings were documented. They were debated. And ultimately, they were dismissed. As investigators reconstructed the final dive, another clue emerged from the debris pattern. The implosion likely occurred during descent, not on impact with the seabed. This meant there was no chance of recovery. No time to react. No distress signal. At implosion depth, the hull would have collapsed inward at nearly the speed of sound. The interior would have compressed instantly, generating extreme heat and force, reducing the submersible's interior to fragments in milliseconds. The ocean floor confirmed this timeline. No burn marks. No scraping damage. No signs of collision. Only evidence of a sudden, total structural failure. Nearby, electronic components were found scattered but recognizable, indicating they were expelled outward after the hull collapsed. This outward dispersion reinforced the implosion theory, contradicting early speculation of entanglement or gradual system failure. The seabed was clear. This was not a slow accident. It was a catastrophic event. Yet one mystery remained unresolved. If the failure was inevitable, why was the dive allowed to happen at all? As the physical evidence on the ocean floor told its silent story, another investigation unfolded far from the sea, one focused not on debris, but on decisions. Internal documents, interviews, and expert testimonies began to reveal a pattern that was impossible to ignore. Years before the implosion, engineers and deep-sea specialists had raised serious concerns about Titan's design. Some warned that carbon fiber pressure hulls had never been fully certified for repeated dives at extreme depths. Others questioned the lack of independent classification from established maritime safety organizations. Instead of following traditional certification processes, the company behind Titan chose a different path. They called it innovation over regulation. The philosophy was clear: move fast, break conventions, and redefine what was possible in deep-sea exploration. But critics argued that what was being redefined was not exploration, it was risk tolerance. Emails and interviews revealed that multiple employees had expressed discomfort with the submersible's structural integrity. One former engineer reportedly described the design as an experiment, not a finished vehicle. Another warned that acoustic cracking noises, detected during previous dives, could indicate progressive damage inside the hull. Those warnings were not acted upon. Instead, the noises were reinterpreted as normal behavior, the carbon fiber settling under pressure. No long-term halt. No full redesign. No external certification. The dives continued. Then came the passengers. Titan was not just a research vessel, it was also a commercial experience. Tickets cost hundreds of thousands of dollars. Among the final crew were wealthy explorers, a renowned Titanic expert, and the company's own CEO. That detail mattered. The presence of the CEO on board suggested confidence, or perhaps belief, that the risks were understood and acceptable. But investigators questioned whether passengers were ever fully informed of how experimental the vessel truly was. Waivers had been signed. Risks had been acknowledged. But could anyone truly consent to dangers that were still scientifically uncertain? As scrutiny increased, comparisons were drawn to aviation disasters and space exploration failures, moments where ambition raced ahead of safety margins. The ocean floor did not lie. The debris did not lie. But responsibility does not rest underwater. It rests with choices made on land, long before the final dive ever began. And that raised the most unsettling question of all. Was Titan's implosion a tragic accident? Or the predictable outcome of ignored warnings? In the months following the Titan implosion, the world was left with more than grief. It was left with questions that refused to sink. As investigations continued, new fragments were reportedly identified on the ocean floor, smaller, more scattered pieces, located farther from the main debris field. While officials avoided definitive statements, experts suggested these findings could indicate the exact sequence of failure, revealing how rapidly the implosion unfolded. According to deep-sea physicists, the collapse likely occurred in less than a second. One moment, the submersible was descending toward the Titanic. The next, it ceased to exist as a sealed vessel. The pressure at that depth, over 380 atmospheres, would have crushed the hull instantly, leaving no time for reaction or awareness. This realization brought a small measure of comfort to some families. But it also intensified the global debate. Should experimental vehicles ever carry paying passengers? Should innovation be allowed to bypass long-established safety standards? And who should be held accountable when exploration crosses into recklessness? Governments, maritime authorities, and exploration companies began reassessing regulations. Some called for stricter oversight of private deep-sea ventures. Others warned that excessive regulation could slow innovation and limit humanity's ability to explore the unknown. The Titan tragedy became a turning point. Not just for OceanGate, but for the entire future of deep ocean exploration. What was once seen as a bold frontier now appeared as a fragile boundary between discovery and disaster. The ocean, vast and silent, had once again reminded humanity that it does not forgive mistakes. The wreckage of the Titanic has rested on the seabed for over a century, a monument to human ambition and error. Now, nearby, lies another reminder. Smaller, newer, but no less symbolic. Two wrecks. Two eras. The same lesson. Technology can take us deeper than ever before. But wisdom must go deeper still. And as the final reports are written, one truth remains undeniable. The ocean floor did not just reveal what happened to Titan. It revealed how fragile progress can be when caution is left behind.